Okay, welcome everybody to the San Diego Kotlin user group. We've got Andy Goldberg today. He's going to be presenting on Kotlin Dataframe. Really excited for the presentation. So take it away, Andy. Thank you for presenting.
Yeah, awesome. Thanks for the opportunity. Appreciate it, Ian, and the rest of you guys for coming out and listening. Definitely. So yeah, Kotlin Dataframe is a part of JetBrains ecosystem. They've been pushing using Kotlin for data science, and in any platform that is taken seriously for data analysis, data science, the concept of a data frame module or library is sort of the central piece of that. So it's really good to see JetBrains stepping up and contributing their part. There was some sort of minimal efforts previously, but yeah, this is a big step forward. So it's really terrific. So the first question is just, what is a data frame? And I just thought it was funny because I think when we mentioned it last month or something, Ian sort of referenced it a little bit like it was some sort of way out there, super complex machine learning, type of project. But in fact, no, it's actually very simple. A data frame is just basically almost anything that you would consider to be a data table or a set of data that you see pretty much everywhere. So yeah, any kind of database query, database table, database view where you have columns and rows, that's essentially a data frame. All your Excel spreadsheets, columns and rows, that's a data frame. Your CSV files, sure you have them all over the place. Also data frames. Web-based HTML tables, these would all be considered to be data frames. And like BI reports, if you're stuck using any of those at work, same thing. So basically any kind of data table is eligible or can be considered to be a data frame. The question is just, getting them into your sort of computer program to start to work with it. And this is certainly not a Kotlin invention. As I was saying, any platform that wants to be a serious contender for data analysis is going to have some kind of module like this. So I first learned about data frames with the R language way back in the late aughts, I would say. Working on some ways of doing a little more complex analysis than what I was doing in Excel at the time, at the job that I had back then. And at the time, like R was like really cool. Like, hey, it's like everything you can do with a spreadsheet, except you don't need to rely on a spreadsheet to do it. You can program it rather than do it all manually. Probably the most popular implementation is Python module for Python, or Pandas module for Python. So it is built off of another Python package called NumPy, numerical processing. Pandas sort of really kickstarted the whole idea of Python for data. Because it made it very simple to import a database table, a CSV, an Excel spreadsheet, all the sources that we just saw before, and then really, do a whole lot of, any kind of modifications in any kind of setup, and then doing the analysis itself. So by far, I would say Pandas is sort of the king, the most popular usage of a data frame implementation. Julia language has sort of gotten popular a little bit in analysis, and this data frames is central to that language. Apache Spark has implemented data sets, data frames. And then when I was sort of looking a little bit at how far, like I said, I knew about it in R. I knew that R was a sort of an open source rewrite of a language called S before that. And do a little history here. They talk about data frames introduced perhaps in 1991. So the idea may go back even further than that, but here's sort of like about a 30-year-old at least mention. So again, it's not a Kotlin implementation, but as we'll see, Kotlin sort of takes advantage of the language and sort of adds to it and makes things a lot better. So the reason that a Kotlin implementation is so welcome is, well, I mean, first of all, obviously we this group and a lot of others, prefer doing our, writing our code in Kotlin over those other languages for a lot of reasons, and a lot of those reasons follow through to their implementations. So the biggest one, I think, is you're dealing with data. It's important to get data correct in terms of types. And meanwhile, all three of the languages we just talked about are dynamic languages. So even though Python now has like type hinting and stuff, it's not really enforceable. Even TypeScript is a more sort of a more stiffer or more policed implementation, I think, than the way Python does it. The other part is the APIs are pretty rough. Our language overall is very quirky, very difficult. The equality signs goes left instead of right. It's very weird. Python, pandas is like I said, it's popular and it does do a lot of things, but if you do a Google search for, pandas API, there's a lot of complaints about it for good reason. It is very difficult to work with. It's not always consistent. Some of the syntax is rough. So for R, there's sort of been a second ecosystem built on top of this called dplayer. I'm not even sure if it's pronounced that. I know how it's spelled, but not exactly how it's pronounced. But they've done a lot of work, and people, have found that to be a good implementation over the base R implementation. And then, like I said, pandas, there's complaints everywhere about it. Even the creator of pandas, Wes McKinney, wrote an article, 10 things I hate about pandas. And part of it was the API. And, he acknowledges that it's difficult and that it's tough. They also, pandas forces you to use these indexes, which can be very useful, especially if you're using a time-based series of data. But for lots of day-to-day stuff, these indexes just get in the way. They're like an extra column. So you have to reference them differently than you reference all the rest of the columns. Not fun, not necessarily fun. So where can the Kotlin implementation do better? So one of the things that's really cool is every function returns another data frame. So it's fully chainable. So you can create these top-down single, they can be somewhat long functions, but it's very simple just to go step to step to step and chain them all and get from your input to the output that you want in a single line, if that's how you want to go. Obviously you're welcome to create lots of intermediate variables, but strong typing, of course, is a huge aspect. You have these columns of data. You want to make sure that when you think something's an integer, that it is an integer. And that it's going to get thrown off if there's a couple of values somewhere in the column that for some reason have letters in them, or even the word null or something like that. So strong typing is really, it gives you confidence that the data you're working with is what you think it is. So one of the really cool things is the creators of the Dataframe created multiple APIs for accessing the individual columns. So I gave a couple of examples out there. It depends partly on how you first present the data, and how you introduce what the columns are going to be. And it can do a lot of the work for you and give you like direct properties where you can access the columns directly by their name, as you see in the first example, where it's like, just df.age, or in this case, over on the right, if you're trying to do something like a filter, you just say age is greater than 18. Accessors is when you want to reference a column, you sort of declare it the way you would declare a variable. And then the only difference is you either have to put it in brackets if you're accessing the column directly, or if you're going to act upon the column, you just have to put the parentheses, so it's like a function. And then if you haven't done any declaring at all, you can use quotes. And then when you use it, you just have to let it know that, okay, this column's an integer, and it'll then let you, do greater than 18, which it wouldn't do if you declared it as a string or something. Another really cool thing is that your cells can contain classes. So you are able to use the internal functions of the classes within the columns. So for example, if you want to represent data a certain way, you can use a toString function as opposed to having to rewrite it yourself. And obviously, other functions that you would add to a class, it's all available to you, as opposed to just working with primitives only. And then, yeah, so you basically have all of Kotlin to work with. Pandas has implemented a ton of functions, but like you have to use its library. So for example, in this scenario where you just want to, you take a string and uppercase it, you can use the native function in Kotlin, whereas in Pandas, you have to use the special Pandas function, and you have to reference it with the str prefix. So it knows you're using the Pandas libraries function as opposed to, say, a native Python function. So just, you're more consistent because you're using the functions you would normally use. And then, of course, it is usable in Jupyter, which we're going to look at. And the other really cool thing is super easy two-way interop. So if you have, if you already have lists and you want to turn it into a data frame, that's super easy. And then once you have a data frame, if you want to turn it into a list or a map, that's also super easy, as we'll see in a second. So this is an example of, on top, that is how you would convert a data frame to a list of your reading class. And, of course, Python, just the declaration of the class is a little more complex with the, init function, and this, you have to remember to put the self. That would always throw me off in Python. But just this single line to create the class, like you have to create the class manually. You have to put in the two properties, and then you have to go through this list comprehension surrounded by the brackets. So this isn't so bad, but imagine if your class had 6 or 8 or 15 properties, and then this thing would go on forever. Whereas in Kotlin, you add this data schema annotation, and the compiler now knows that, hey, I might want to do something with this reading class as far as my data frame goes. and then boom, all you have to do is to list of, that's it, no parameters, no anything. And it's that easy to, as long as your data frame obviously has to comply with the columns that are there. But yeah, it's super easy. And the same going the other way around. If you had a list of classes, it's just data frame of, or sorry, to data frame, same way. So very simple, easier API than Python. So again, what's the whole point of this? What can we do with a data frame? So of course, when you get data, more likely than not, it's not going to be in a perfect format. It's going to be a lot different than how you need it to be to do some sort of analysis. One of the jokes or whatever, for data scientists is that the cleansing of the data is, 80 to 90% of the job. They don't get to actually do the big PhD level, the deep stuff, until they go through the whole process of doing all this cleansing. So a huge amount of it is this kind of stuff: sorting, filtering, adding new rows to the bottom of it. Of course, you want to get, summaries to be able to, how many rows do I have? What's the sum total of these columns, the averages? What's the min, the max, things like that. Once you start to get it in a way that you want it, you can start doing some editing, some calculations, take two columns and multiply them and come up with the product, or, all kinds of things. Okay, well, data cleansing I have here. Obviously, yeah, lots of data comes in with nulls, missing data. You need a way, do I turn all the nulls into zeros? Do I just delete the rows that aren't complete? How do I handle all that? Categorizing. So lots of data comes in and you may want to group it, like we saw on the previous slide with age, greater than 18. You might want to, instead of working with a whole continuous range of ages, you might just want to have, toddler, teenager, young adult, senior citizen, something like that, or, any kind of categorization. So makes it a little bit easier. You can do that kind of stuff. It's also known as factorizing. A huge one is joining with other data frames. So with databases, we do inner joins, outer joins, take this table, that table, and combine them together on some key column or set of columns. So that's a huge function that's really important. Here, pivoting, where we take the rows and turn them into columns, columns into rows, things like that. And then preparing for plotting, to do charts, visualizations, all that kind of stuff. So data frame helps with all that. So as I'm going through some of these functions, you might say to yourself, hey, wait a second, I can do all that stuff with SQL, especially. I can do a lot of stuff in Excel. I can do a lot of this stuff in some of these other tools. Even with Kotlin collections, right? If I have a list of classes, I can certainly filter them. I can certainly sort them. So, what's the need for a data frame? What does it give me that these other things don't? So one of the things is a lot of our data is not sourced from a database. So SQL is an excellent, mature tool, but if your data comes out of Excel or comes out of a BI tool, or someone sends you over a CSV export of some report, then SQL is not available to you. So you need some other tool. Yeah, or you might have multiple servers, right? You might have data that's sitting across 3 different servers or in a bunch of different tables. One's in SQL Server, one's in Oracle, one's somewhere else. And you could use SQL if they were all in one server, but since they're not, it makes it either really difficult or slow or impossible to do. As far as using collections, the data frame has a lot more flexibility, right? Because we can add new columns. You can't just randomly add a new property to a class that you've already defined. If you have vals in your classes, immutable properties, you can't change them. Whereas with the data frame, you have a lot of flexibility. You can add columns, rename them, all that kind of stuff. We'll also see with the exploding, which is sort of like for every row, you might have 3 different versions of it. Or pivoting. Yeah, we'll see some of these examples in a minute. The other part is the data frame should work faster. I'm not really 100% sure on how the internals work, but when you do like a mapping on a list, it iterates through one by one each object in that list. Whereas I believe, I know this works in other implementations. I believe it uses, this like vector math and stuff like that. So a function gets applied immediately to the entire row all at once. It's column based rather than row based. So instead of iterating through each row, the column the formulas are applied to the column, and that should make things a lot faster, especially when you have a lot of data. There is a lot of overlap with SQL. So even if the first 2 don't apply, even if you are sourcing your data from a database, and you could do things in SQL, again, you have a wider range of functions in Kotlin. You have the ability to work with classes and define a method inside of a class that in SQL would be very difficult to create a separate function for reuse. You have collections. So SQL Server, for example, still does not allow you to put an array data type. So you can't have a SQL Server column that has a list or an array. Postgres has moved well beyond this. It lets you use arrays, it lets you use JSON documents inside of a column and query them. But a lot of SQL implementations don't have that. So again, you have a lot more flexibility. So here's from the documentation, data access, data frame support, CSV, TSV, all these things. You'll notice that there's no SQL on here, right? So obviously as we've been talking about, one of the big sources is pulling stuff out of a database. And data frame, Kotlin data frame does not support immediate direct access to a database. So I could see this being on like a feature list somewhere where like the Python version would have a big check mark. Of course, we allow you to write SQL query, and Kotlin doesn't. So obviously we're better. I disagree. So obviously Kotlin JVM has tons of, I won't say tons, but they have a number of ORMs that do enable you to query a database and do it in a type safe manner. And any of those can take the results and turn it into a collection. And all you have to do is add to data frame at the end. So I would actually rather work with my own choice of an ORM based on, let the ORM do its thing. Pandas does allow you to write SQL, but again, it only allows you to write like a SQL string. There's no object orientation to it or anything. And so Python, obviously is a scripting language. When I use Python, having a big SQL statement in the middle of my code didn't bother me so much because everything was sort of undeclared and stuff. But in Kotlin, to have, everything, with a type and everything, and then to all of a sudden have like a big SQL statement, it's just one of those like it doesn't look right and it doesn't feel right. I'd much rather do my queries in a type safe manner. And it just is consistent with everything else. So it's super modular. So the fact that data frame doesn't natively import from a database. Anyone who would say that would be a negative, that's just that's FUD. That's BS. It's like I said, you have plenty of database accessibility options. Okay, so we're gonna do an example here, and so what I sort of did this. This is a Jupyter notebook. If you guys are not super familiar with that, and that's sort of the primary, I guess, UI for, experimentation, data analysis, and stuff like that. So the Jupyter notebook was originally a Python project, and it's still a Python. It still relies on Python to run, but the underlying kernel that is executing your code, they have expanded it to dozens of different programming languages and stuff. And you can see up here, we're running the Kotlin kernel. So I brought in the imports that I need, the data frame, and then the let's plot. We'll do some visualization at the end. So I have this spreadsheet. You guys are able to see the screen, right? It's not. Okay, yeah, it's not limited to just the print. Okay, so this was a Excel spreadsheet that I found, and it was actually, it has so many things going for it in terms of being good for doing a demo. So it's got every NFL game going back to 2006, and it's got the teams, the score, characteristics. Was it an overtime game, playoff game? And it's got odds. So basically it helps you determine, historical odds for NFL. So we're going to use this and do a relatively quick, relatively basic data analysis project. We're going to try to figure out which teams have been the most profitable to bet on. So the first thing I'm going to do is bring in, I'm going to read Excel, and that's my the name of the sheet. All right, so the first thing I do is I want to just make sure I got everything as I anticipated, so I can just see what my so I have this data frame now, data frame raw. So real quickly, just looking at my column names, you can see home score, away score, home odds close, home odds open, minimum, maximum close. They do away, they do the line, the point spread, and then the odds on the over under, all that kind of stuff. So let's see if I can get some basic info. The describe function is going to give me, a quick summary, and then we'll see, okay, it's giving me an error. There's something up. So I want to, let's see if I can take a look, and I can see here of all my columns, I have a comparable, and then everything after that, string, double, those all look normal, but the comparable is what's giving me a problem up here, because it's supposed to be a local date time. Okay, so we can real quick, we're going to do our first conversion. So df raw. So as you can see, Jupyter, the Kotlin kernel, it's super. It gives you, the hints. We're going to do a convert, and we're going to take the game date column. And as you can see, I don't have to put it in quotes. It already knows that there is a column named game date. So I'm able to access the columns by their names as if they were declared variables. Like I was saying, if I was doing this in another language, I would have to use quotes, be subject to misspelling. You certainly wouldn't have the preview, the type hints and stuff like that. So, of course, I've done this, so I'm not going to spend all the time typing, but the issue was some of the local dates only had the date, some of them had the time component to it. So if I convert it and make sure I have just a local, if I convert it to a string and then to a date, and now I'm going to describe. And now I have a quick picture of what I've got here in my spreadsheet. So as you can see, here's all the columns, the count 4,400. So I know I have 4,400 games. It tells me how many unique entries in each column. So for things like overtime, it's just a yes or no, or in fact, it's actually yes or null. Home team, there's 37, and I can actually already see I have a little bit of a problem here because I have the Washington Redskins as the max. I already know the Washington Redskins don't exist anymore. Las Vegas Raiders is also sort of a hint that, hey, wait, I might have to do a little more cleanup here. And right, so if I decide, hey, wait a second, home team, show me the distinct values and sort them. Yeah, this shows me, real quick what I was concerned about. I have Washington Redskins, Washington football team, and Washington Commanders. I also have the San Diego Chargers, which is the San Diego meetup group. So we know they're long gone and they're now the Los Angeles Chargers. Same with the St. Louis Rams, no longer exist. So I'll create a map of the old teams to the new teams. And that'll be my map. And now we start to see the chaining of the functions as we were talking about. So we did the convert earlier. We still have the df raw. We still haven't, that's still our only variable that we've defined. So so just by converting it, it didn't change df raw. It's still the same thing. So any further uses of it, we still have to redo the conversion. But we're also now going to update so that anything, the home team and the away team columns now will be converted with our map here to to the value. And now if we describe our new data set, now we only have 32 unique team names, and Washington Commanders is the max. We haven't changed anything with the rest of the data yet. We're going to do this relatively quickly so we can make a few more cleansing things. We can decide, let's drop any ties. It's there's not too many of them, and it's just going to mess up our analysis. So since we're doing it sort of quick and dirty, we're going to drop anytime the home and the away score are equal. And then we're going to add columns, the winning team and the losing team, based on which is greater than the other. So again, we can describe it. And now we had 45 rows. Now we have 47. So we added 2 additional columns, even though we can't see them right here, right now. And then we're also going to, like I said, the overtime, the playoff game, they have just Y and null. Yeah, so we're going to just turn that into a Boolean. So if we go back and we add this right here, and now we rerun it, does that do it? Oh, yeah, it did, right, because we have false and we have false and true as our min max, right? So now we have Booleans to work with. Another thing, I don't know if you guys are super familiar with betting odds and football betting, but one issue with this spreadsheet is it lists all the odds in decimal format. So what this tells you is what would you get paid back if you made a $1 bet? So for example, just using this one, $1.38 off a dollar bet. So you're not getting back a full dollar for every dollar that you bet. This is telling you that you bet on the favorite at about a 3-to-1 clip, because if you bet $3, you get 3 times $1.38, so about 14 or something. So yeah, so without going into too much, I find American odds much easier to work with, which are what are known as plus minus odds. So we can create a single class of our decimal odds, but it's going to calculate the American odds for us. So this is a shout out to Ian, because I know we talked, I think it was last month, or where we had a little conversation about using the inline, the value classes. So here's a perfect reason for that. I could just take decimal odds as a double and just do a conversion function, but it's better to have this class where I can, again, require that the decimal odds are greater than 1, so I don't have a screw up. And then, use this American odds function, and, I still have access to the old way. So that's kind of cool. And just to test it out to see if it works, I'm going to take a bunch of decimal odds here, list of double, 1.2, 1.5, and then print them. And then I'm going to map it using this decimal odds and see if that comes out correctly. And yeah, it does. So again, I don't mean to go over anybody's head, but at the same time, this doesn't need to be a seminar on sports gambling, but basically decimal odds of, 1.909 is equivalent of what you would call a minus 110, which is your standard point spread bet. And things like a 9.0 is equal to 8-to-1 odds, or plus 800. So that is working correctly. I'm going to do something similar with the point spread, because we want to represent it with pluses and minuses. And also game day, we're going to use this value class will get us a chance to make it real easy to figure out what month we're in, what day of the week. As you know, not every football game is played on a Sunday, and sometimes that's interesting to bettors, gamblers. So here's where we declare 2 of our columns that aren't going to be automatically available to us. And that's why declaring them is pretty key. So we're going to take a lot of the stuff that we've already created. And this is where this chaining stuff becomes really, really cool, because I'm finally going to declare a new variable, a df, and are starting with df raw. And now we've already done these first 3 commands. We've converted the game date column into actual local dates. We've updated the home and the away team with the mapping so that they have the current team names. We converted these 3 columns into Booleans. And now we're going to add the conversions to any column that contains the word odds. We are going to make it a decimal odds class rather than just a double. And having this Kotlin name contains as part of the data, like that is a huge shortcut in itself. If I was doing this in SQL, I can't iterate over the column names. I would literally have to go in there and take, I think there's like 16 or 20 columns and run the same function on every single one of them or in the same SQL code. And in some cases, I may not know what the column names are, or don't feel like inspecting them all. So that would be like a big slowdown. The same thing here. If the name contains line, except if it also contains odds, then we're going to convert into a point spread class. Okay, like I said, we're going to drop the ties. We've done that. And then we're going to add a bunch of new calculated columns. So this is where the declaring, as we saw up here, when you do this in Jupyter, the data frame does like this shortcut where it reads your data frame and is able to convert every column into a fixed variable. But since we're creating some of these on the fly, we still have to use quotes. If we stopped here, and then created a new variable, then these would all be available to us. But all we have to do is declare them as Boolean columns, and then it's easy to use them without using quotes. It's a little more complicated in compiled code when you're not using Jupyter, because you do have to declare schemas. But again, it's super easy. Sometimes you mix and match the quotes with the accessors, with the fixed properties, and that's the flexibility that gives you. And then we're just going to move these around. So, yeah. So I can run this as a single chainable declaration, and then I'm going to describe my new frame here, and I've got 54 rows, so I've got 54 columns in the data frame. Now everything I've done before is all my cleansing is done, and you can see here in the home odds close, it's now represented as a -185. That's American odds. These point spreads are listed as -3. Also, that's how it's represented normally. So it just looks a little more normal. Again, I want to do some sanity checks. So I want to make sure my value counts, home line close. So I can see all the point spreads and how frequently they've come up. And if you know anything about American football, it's not a surprise that -3 and 0.3 and +3 and then 3.5 are the most common point spreads, because that basically means it's a field goal difference between the two teams. So it would be expected that we would see 3 points as the most common, and then 7 right after that. Whereas numbers like 5.5, 4 points, they're in there, but far less common. Only 90 total at 4 versus almost 500 in the 3s. Of course, as I mentioned, we have the ability to plot some of this stuff. So all I have to do is tell it X is my home line close, and say I want a histogram, and now I can see the same thing, but just in a graph. So again, it's just a sanity check. I can see that the 3-point line is the most common. The -3 is the second most common, or sorry, -3 is most common. It's represented as the home team. So +3 is second most common, and 7 and 3.5. So yeah, another sanity check would be to check on what team has won the most games. And again, if you're familiar with football, New England Patriots are obviously at the top, 214 wins since 2006 when our data set is. because they won a whole bunch of Super Bowls. Green Bay Packers are next, Pittsburgh. Yeah, so this one, so again, this gives us confidence that the data that we're looking at is correct. And this also, this indicates what I was saying. The data cleansing is a huge part of the analysis. But doing this with the Kotlin data frame, where everything's typed, where everything is accessible via a name, there's no misspellings because of something in quotes. And all these functions are like super easy to find. Yeah, we're just doing things a lot faster than we would in another language, in my opinion. So here's where I was talking about, factoring or categorizing things. So we can take that. Sorry, this was part of my point spread value class, where anything less than a 3-point game, we call it a tight spread. 3 to 7 would be medium. Up to 10 is a large spread. And then if it's more than 10 points, we'll call it lopsided. So instead of working with a continuous range, we can divide it into just 4 categories. And those are available to us, and we can see the distribution. Now we can get into doing some actual analysis. So again, I'm gonna just sort of use some stuff. We're gonna drop all the rows where the closing odds weren't available to us. We are gonna add some profit calculating columns. So if the winning team is the home team, then if you bet on the home team, you made a profit. If you bet on the away team, you lost money, obviously. And if we do that, now we can start to see some individual rows, and we can start to see, for example, I don't have the games that were played this past week, but we can see games just last weekend. If you remember last Monday night, New England was a big favorite against Chicago Bears in New England. The odds were the home team was minus 400, meaning you had to, if you had to bet 400 to win 100. And the point spread was the home line closed at 8.5-point favorites New England were. But they lost. The away team, the Chicago Bears, won 33-14. So this was a big payoff. So if you bet on the away team, for every dollar you bet, you made a profit of $3.2. So that's your profit. You got paid $4.20 for every dollar. So that was a day for the away. That was a game for the Bear fans and for the away fans. And as you can see, we have this calculated for every single game, every single row. So now if I start to do some aggregations, so I want to set my row limit to 50. I keep running into getting cut off at 20 rows here. So I want to see a little more info. I'm going to set my row limit to 50. And now, okay, so now we're going to do some cool stuff. We're going to group by the home team. And then we're going to aggregate. I want the average wagering profit and the average wagering profit on betting odds, betting on the money line, and then average odds on betting the point spreads. And now I want to sort by the most profitable team, descending, because I want the top team first. So now, after doing everything above us, we can find out that over the past 15 years, well, less than that, because we dropped a lot of the old ones where we didn't have a closing line. So we started getting them 2014. So over the past 8 seasons, betting on the money line, the Miami Dolphins have been our best bet. They've been profitable to the point about 30 cents for every dollar that was bet. And they're actually way ahead. Pittsburgh is second, but they're half of that, only 15 cents per dollar bet. But you can see for the most part, there's not much profit to be had. I mean, most of the teams are negative. And then on the point spread side, I didn't sort, I sorted by the money line side, but you can see there are even more negative numbers. Here's 15 cents on New England, 13 cents on Minnesota. But that's to be expected, right? Betting on football means you're paying a vig to the bookie in every situation. You know, point spread bets, you have to bet 110 to win 100. That's the edge. On money lines, the edge is that they don't give you the true odds, you know, that you would bet 150 to win 100 on the favorite. But if you bet 100 on the underdog, they don't pay you 150. They might only pay you 120 or 130. So they keep that amount in the middle. But that being said, Miami did come out positive on the money line, and a couple teams came out a small amount on point spread profit. Now that's looking at all their games. So we might say, hey, well, I want to look at a more situational analysis. So let's take this whole thing and let's filter it down a little bit. Okay, let's take out playoff games because those are two strong teams. Let's filter on just games within since 2020. Let's group by the team, but also the month of the year. And now we're going to look at away teams. So sometimes there might be some value betting teams that are on the road because they look like they're bigger underdogs. And now we find out that, okay, when you filter things down a little bit, now you have some profit opportunities, potentially, of course, as they always say, right? Past results are not indicative of future profits. But this is pretty interesting. If you bet on the Jets in December, month 12, they've only had 3 games, and they had to be the away team, and we're only looking back 3 seasons now. So they've only had 3 games in December, but for every dollar that you bet on the money line, you made a profit of $3. So that's obviously way ahead of anybody else. Although you'll find, you know, there are obviously a lot more opportunities. There's a bunch that are more than one, meaning you're doubling your money or something like that. So the question would be like, well, what the hell? How are the Jets so profitable? Did they win all 3 of their games? So let's take a little bit closer look at that. Let's just filter out where the away team is the Jets. Game date was after 2020, and the game month was in December. And okay, here's 3 games. They played the Dolphins, they played the Rams, they played Seattle, and they were the away team. Well, they lost to Miami on December 19th of last year, so that obviously wasn't profitable. And it looks like they got killed by the Seattle Seahawks 40-3. So what's going on here? Well, they did have this one game where they did 23-20 against the Rams. This is in 2020, December 20th. And you start to look at, oh, wait, home odds, minus 1,600. Okay, so the Jets were a massive closing line. They were a massive 1,100 underdog, meaning they were 11-1. The point spread was great, was 17. The home line was, minus 17. It's very rare to see a point spread above 2 touchdowns in the NFL. But obviously the Jets, you know, have been terrible for a long time. The Rams were pretty good. And meanwhile, the Jets, though, did upset them 23-20. So they got a profit of 11 on this one game, even though they lost the other 2. that averages out, the sum is $9 profit, 3 games. So the average is 3. So that's where we get our $3 profit. So that gives you a little more color if you're thinking about, should I bet on the Jets this December? Because it's not like they went 3-0. They had one huge upset, but they lost the other 2 games. So it's not like it's money in the bank. It's one, huge win. So that would give you a little more info. And, of course, you can look at breakdowns of these other teams and look on the point spread side and all this stuff. And you can do tons more situational analysis, all that kind of stuff. But for right now, we're just going to take it that the Jets are clearly the best bet in the NFL, and anyone who would bet against the Jets is lunatic and obviously deranged. So there we go. So I'm going to stop there with the analysis, but that that's sort of a good, everything we did was via Dataframe. We didn't do this. We didn't convert back to, a list or a map or anything like that. All these functions are native into Dataframe. We hardly had to create any variables. Of course, if you were sort of creating an odds program or some sort of consumer-based analytics thing, you might take some of the stuff that we did and put it into compile code and all that stuff. But now that we have done the experiments here, now you can convert it piece by piece and all that kind of stuff. So that's the difference between the Jupyter environment and sort of a compile code environment. So yeah, let's get this back up real quick. And right. So yeah, again, why would we, a lot of the stuff that we did, again, why necessarily do it with Kotlin's data frame? Why not do this in some of these other tools that we're familiar with? People be using Excel forever and doing that same analysis in Excel. Like we saw here, the benefits have to do with the type safe development, having everything, all the column names fixed, being able to utilize all those Kotlin classes. You could create a lot of the formulas we created in Excel, but then, every time you have to copy those formulas down through thousands of rows and all that stuff. That's where you get to these problems where Excel analysis got screwed up because, the formulas didn't get copied, or they get copied incorrectly or something like that, and it got all messed up. The other part is, as we saw, that analysis, that spreadsheet was updated up until the previous week. So if I'm like updating this every week and I'm copying in new code in Excel, I have to copy everything down and manually resort and manually refilter. Whereas in a data frame environment, when it's running code, your functions do all those things. It's like a script that goes from top to bottom and spits out all your output every time. SQL's great, it's very mature, but trying to add new functions is very difficult. Changing data is sometimes very difficult in SQL. There's ETL processes that will do filtering for you or combine stuff. ETL tools tend to be very expensive. The other part is they start out real easy. They'll show you some screenshots of like arrows pointing, and it's like, oh, I can follow this thing. But then as soon as you want to do like comparisons, do a greater than, you have like drop down boxes. You can't just like write it in code, and we're programmers here, so that gets old very, very quickly. And the if then stuff is also huge. You can't write a SQL query that like, I want to use this view if this is true and that different view. You can use case wins in SQL, but you can't like totally branch off. So for me, I've by incorporating Dataframe into my process, database marketing, from a practical standpoint, I'm starting out with 3 database sources and have to generate 6 CSV outputs. This is a very sort of, this isn't even the whole thing, but this is sort of a basic mapping of some of the data mangling that I have to do to generate mailed offers to a variety of casino customers. So to those who, I should introduce myself, but I'm a consultant in Las Vegas. I work with casinos, helping them with their database marketing. So they have 100,000 customers that they want to send personalized offers to. Some people are going to get $100 in free play. Some people are going to get $500. Some people are going to get $10. Some people are going to get dining coupons. Some people are going to get 3 free nights in a hotel. Some people are going to get 3 free nights in a suite. Some people are only going to get 1 free night. Some people are going to have to pay $59, all that kind of stuff. So we want to take the player's activity and generate the correct offer for them. And then I have to generate a mail file, an email file. I have to update so that our casino management system, when the player actually shows up, knows which offer they're actually going to get. Our kiosks, we have to check our liabilities, our hotel system, everything. So when I first joined, I did most of this in SQL. I created a very long database heavy process. And lots of PTEs, lots of views. But I'm creating, like, part of it is creating a mail file, like literally I'm formatting strings in SQL. And then if it changed, which of course in a business environment, it always does, I have to like create a whole new view or alter the view. That's not how you want to do things. This is just a screenshot of like some of the views that I have. And, if you're familiar with SQL, there's no like code organization or anything. It's just a flat list. You can see some of my V1, V2s, but you don't have modules. You can't put things in folders and stuff. It can be very difficult to work with on a day-to-day basis. This is a snapshot of what an example of just one of the queries. And you can see all these with statements. They're all individual queries that are based on the ones above them. So here's a query, here's a query, here's a query that comes from the 1 year, the 2 year history. ADWs is based on this one, and it just goes on for a while. This is not good code organization, and this is just, like I said, just one of many. This is one that had to do with some pivoting. With here's some text formatting in here with the free slot play, dining comps. How do we want the numbers represented? So again, when the VP would be like, let's change the wording a little bit. I'm changing like a whole database view just for these small things. It's not right. Here's some pivoting stuff, which in SQL to do, you can see the pivot keyword there. You have to like know what all the fields are going to be. You have these atrocities of code. It's not good. That's all I can say. Dataframe just makes a lot of this stuff way easier. And it does a lot of this stuff, again, in a type safe manner. So yeah, I wasn't able to get, show you like live what my process works, but it's basically down to like a button click and stuff like that. I'll try to give you a quick just peek at if this comes over. If this comes over, you can see this. I'm still bringing in data via SQL queries, but like I said, I'm doing it with a type safe ORM. You can see my select, where, everything is type safe. But yeah, and then I just do 2 data frames. So I take the SQL result, turn it into the class it's supposed to be, 2 data frame. That's it. That's my only line necessary. And then here's where I do a little bit of explode. I mean, for every tier, I'm creating a slot and a table, slot machine versus table games. Here's where I'm creating some of the inner join, because I pulled in a bunch of different tables. So I'm combining on the month of the offer, the player tier level, and their game preference. So again, I'm emulating an inner join in SQL, but I'm doing it with tables that may not all be sourced from the same place. And then real simple, just chainable, sort by, move, convert. So it's pretty obvious what I'm trying to do without having these massive SQL statements. So the process is complex, as I showed on that map. There's not much I can do I can't eliminate the complexity, but I can try to wrangle it. I can try to make it easier to manage. And I think that doing it in Dataframe does. I mean, I'm going from top down. I'm not, and I'm doing it with one-liners, not an entire query just to add an extra column or reduce the number of columns or to do an if-then statement and stuff. But I'm creating the mail file in this just one little section, and that has its own filters, an email file right after that, and then the files that I need to upload into those other systems is done in another module, but that's pretty easy as well. So yeah, it's sort of hard to really explain it, but it has been a big help. So, of course, not everything's perfect. So like I said, the project here is definitely still beta mode. You do have to sort of figure it out a little bit. Some of the complex functions like pivoting, some of the conversions, some of the calculations are a little tough to figure out. Documentation's not great, but a little intuition does go a long way. I've managed to eventually sort of figure things out. The roadmap isn't really there. We don't know when they're coming out with the next release, things like that. So there's like being able to rely on, hey, this is coming soon. Not really. That being said, there is an enormous amount of functionality they've already done without even being at a 1.0 yet. Range lookups are a big thing. That would be helpful. I still haven't exactly figured out how to do that. That would be the equivalent of, Pandas has that with this merge as of an Excel VLOOKUP. You can do a VLOOKUP if you're matching exact, but if you're familiar with Excel, you can also set VLOOKUP to look in a range, like anything from 100 to 200 is in this bucket. That I can't do right now. Don't know about speed, don't know exactly about dealing with, huge data sets. And also, again, it's not just Dataframe. Let's Plot is a very cool module, but it also lacks some documentation. So when you're doing heavy on charting, visualization, you might run into some roadblocks in terms of figuring out how to do things there. So, all right, went a little bit longer, but here's my contact info. More than happy to answer any questions that you guys have now. If you want to hit me up afterwards or anything like that, here's some ways to get in touch with me. But I definitely really appreciate you guys sticking it out. Hope that you learned something. Hope that this was interesting, and hopefully it gives you some, incentive to be like, hey, all right, this thing is actually pretty, I think I could figure it out. It's not super complicated or anything like that. It makes some sense, and it gives me the opportunity to wrestle with my data in a, like I said, a manageable format. So it's definitely been a huge help in a professional environment, but also, for doing little side projects and stuff like that. So it's definitely a huge asset to Kotlin, and the team behind it really deserves a lot of credit for the work they've done so far. And I know the stuff that's coming soon, and they're out there, they're in the the Slack. They're out there on Twitter and stuff. So I sent a note to a couple of guys when they announced like 8.0 or 0.8 release or something. I was just like, hey man, great job. So yeah, so cool. Again, thanks very much. Appreciate it.
Fantastic, Andy. Thank you.
Yeah.
I see Shendil has a question in the chat about whether it's github.com/Kotlin/Dataframe is the home for this project. That seems right. It looks familiar to me.
Yes. And yeah, I mean, you can, I forget offhand, but that's obviously the GitHub, but the documentation site is one of those GitHub IO things, I think.
Right. Yeah. GitHub sites.
Yeah.
Cool.
That's where the docs are. And, you definitely, like I said, you got to read it. Sometimes it doesn't click automatically. Wait, how am I accessing this column again? Especially because there's nested columns are available and stuff. So how do I access those again? But sometimes you can go back and some of it's in the docs, more time, but sometimes not. But a couple of times when I was like pounding my head, I would just take a break, go back, find it on the page. Oh yeah, there it is. Okay, it's there. Yeah.
Excellent. Does anyone else have any other questions for Andy? I had several, but then you answered them as you went through your presentation. So great presentation.
Okay, good deal.
you got to pretty much all my questions that I had.
Okay, awesome.
Yeah, it was really good. Anyone have anything else?
I see a hand up there.
I think that's a clap. I think you're getting applause.
Oh, awesome.
You're getting virtual applause. Yeah.
Nice. Awesome.
Cool.
Yeah. No, thank you. This was great.
I really appreciate that. Yeah, thanks very much. No, it ended up coming out good. I sort of whipped it together, but yeah, no, it's just like I said, it's a tool that I found to be super useful. So glad I was able to. I'm glad that you were able to get that from my enthusiasm, I guess. Yeah, awesome. Thanks. Appreciate you saying that.
Excellent. All right, well, we'll wrap it up here as far as the recording's concerned. People are welcome to stay on. We can do some more Q&A, some closing thoughts if we want. And but just one final thing for the recording. Thank you, Andy. This was really great.
Thanks. Yeah, awesome.